going to look at graphing a system of linear inequalities. And actually, when we graph this, we're basically going to essentially graph each inequality. So like we'll graph each. So graph each, and then we'll shade our solution. And the easy thing about these problems are wherever this shading overlaps, that's the actual solution. All right. So let's take a look at what that actually would look like. So let me actually do this. That way we don't lose our graph. All right, so we're going to have two inequalities once again, and now we're going to graph both. And in a previous video, I actually graphed inequalities individually. So if you want to, I would go back to that, take a look at it, because it has some good information. So we have y is less than or equal to negative 2 over 3x minus 1. That's our first inequality. Our second inequality, and I'll actually do these different colors, is y is greater than or equal to 1 over 2x minus 8. All right, so now our job is first of all to graph our first inequality, and I'll actually just keep the colors consistent. So let's graph this inequality. So our y-intercept is negative 1, so our first point is going to be right here. And then our slope is negative 2 over 3, so we're going to go down 2 and to the right 3. So 1, 2, 3. And then you could make a couple more points if you really want to. We could go up and to the left. 1, 2, 1, 2, 3. All right. So now, if we want to draw a line through this, we just have to make sure that we do this. We need to double check our inequality symbol and see if this should be a dotted or a solid line. And since there's a line under the inequality symbol, we're going to make a solid line. And I'm going to cheat a little bit because I struggle to make lines that are straight. That one looks pretty straight. That one looks pretty straight. Maybe it's a little crooked, but that's okay. I think you get the idea. All right. So there's our first line, even though it's a little bit crooked. Now let's do the second line. Well, actually, before we do that, let's go ahead and do our shading. I almost forgot to do my shading. So we have y is less than negative 2 over 3x. So less than tells me to shade under. So I have the advantage of using different colors. Unfortunately, most of you don't have different colors. You're just using like a pencil. So when you shade this, I would make sure to lightly shade this. So shade it lightly just so you can tell where the shading is, but don't go hard. Like I wouldn't go hard in the paint with it and make it super dark. Okay, so make it a light shading. So we did it on the bottom because it was less than. So now let's go to the second equation. So my y-intercept is going to be negative 8. So I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8. So all the way down here. And my slope is 1 over 2. So I'm going to go up 1 over 2. I can make as many points as I need to. I'm just going to make a couple more points just so I can see. And then once again, before we draw a line through that, we want to see if it's dotted or solid. And it would be solid since there's a line under our inequality. So once again, I'm going to cheat a little bit. That looks pretty straight. Let's draw another little spot right here. If only I could draw straight lines, I would be a better person. All right, so there is our line. Now we just need to make sure our shading is correct. So now when I shade this, it's greater than my inequality is. So I'm going to shade above. So once again, you want to lightly shade because you want to make sure that you leave room to dark shade in your answer because that's what we're looking for. We're looking for where's this going to overlap. So if I shade above this, it would all kind of look like this. Okay, now I'm going to make it, I'm going to do it a little bit lighter just so you can see. But if we did above, you can see that all of this part would actually be what overlaps. I mean, I could shade up here, but you can see that my blue line's not shaded up there, so that's not going to overlap. So now our answer is wherever that shading overlaps. So I'll even do it purple just so you can see. All of my shading overlaps right here. So you could just do that and shade it. You could go, you could use this method. You could shade lightly for both, and then shade really heavy for the solution. Or you could even do this. You could just make, you could just draw an S where the solution will be and shade it in. That way, whoever's grading, or like if you're taking a test, whatever you're doing, that way you can see where the actual solution is. So like this is where my solution actually is. Now, what that means is this. If there was a point in this shaded area, that point would be a solution to both these inequalities, okay? So that's all we have to do. So now let's look at another problem just so we can get an idea, and I'll actually try to throw a curveball at you with this one, but I think most of us would be okay with it. All right, so let's do this problem. Let's say x minus y greater than 1, and we'll leave a little room, and we'll say x plus 4y greater than 20. Now, here's the issue with both of these equations. Well, they're actually inequalities. But here's the issue. We want this to be in slope-intercept form, and both of these problems are not in slope-intercept form, or both these inequalities are not in slope-intercept form. So make sure you remember, we just want to isolate y. If we isolate y, as long as our math checks out, that's going to be slope-intercept form. So we're going to subtract x here first. Now I have negative y greater than negative x plus 1. Now, to get rid of that negative in front of y, I'm going to divide by negative 1. And I'll divide this entire side by negative 1. So I'll say y is greater than, but I'm actually making a mistake. Hopefully you see the mistake I'm making. When I divided by a negative 1 on both sides, this is an inequality. So that actually flips, and it becomes x minus 1. So that's my first equation. Now let's go ahead and do our second equation, then we can graph both. Or actually, let's just go ahead and graph this, this equation, just to make it easy. So we're going to start off at negative 1. That's our y-intercept. And then our slope has no coefficient, or we can't see a coefficient. But remember, that's just an understood 1 here. So our slope is actually up 1 over 1. So up 1 over 1, up 1 over 1, up 1 over 1. We could kind of do this for as long as we needed to. All right, now, this one's going to be a little bit different because now if you double check your inequality symbol, you'll see that we're actually going to have a dotted line, all right? So we need to have dotted lines that go through the lines that I just drew, or the points that I just made. Let's see if I could make this straight. Once again, I would be a better person if I could draw straight lines. All right, that looks good enough. All right, so that is our first inequality, but we've got one more step we need to shade. So this says less than, so we're going to shade it below. Once again, I have the advantage of using colors, but when you're using a pencil, just lightly shade that solution. That way we can make our overall solution dark. All right, so then the last step is we need to get this second inequality in slope-intercept form. So we're going to subtract x. I think most of us by now are probably pretty good with that. 4y greater than negative x plus 20. And now we're going to divide by 4 on both sides. So we would end up with y greater than negative 1 over 4x plus 5. So that's our second equation. And actually, I'll do this one in this color, just so we can keep them separate. All right, so now my second equation is going to start at 5. 1, 2, 3, 4, 5. It's going to be a y-intercept, so it's on the y-axis. Now I'm going to go down 1 over to the right 4. So down 1 over 1, 2, 3, 4. I could make another point if I wanted. 1, 1, 2, 3, 4. All right, so now I want to double check that inequality symbol to see if it's a dotted or a solid line, and it would actually be dotted. So we're going to make another dotted line, which is so fun to try to do when you can't actually just draw it. All right, let's try to go this way. I'm not even going to worry about making it super straight. That'll be good. That'll be good. It's a little jacked up, but that's okay. Once again, I think you get the idea. All right, so there's our second line, and it's a dotted line. Now, when we shade this solution, we want to make sure we lightly shade this as well, and it says greater than. So it's actually going to be above, which would be up here. Now, our job is to look for where do the purple, or where does the purple and the blue mix, or where did your light shading mix? And this one's actually a sneaky one. It's actually all this right here. Because if you notice, below this purple line would be in this little red area, and above this blue line would be in this little red area. So that's actually where my solution is. And once again, you need to make sure you draw that dark, and you could even put an S there and kind of make it a dark looking S. That way whoever's grading your paper knows, okay, that's where the solution is. All right, so once again, the good thing about the system of inequalities, the good thing for you is you've already probably done single inequalities. So now you just put two inequalities on a graph, and wherever the shading overlaps, that's our answer. So like this shaded area would be our solution. All right, and actually I can do that in a brighter color. So like this area right here is our solution. All right, so just remember, lightly shade both inequalities, and then you can shade dark for your solution. All right, so that'll be it.